turns out I kind of tricked you on that one. The eruption didn't happen until March 22nd, and if you look back at the data you were looking at, it only went to February 2nd. So there's this harmonic tremor here, and what that tells us is that harmonic tremor definitely gives you an indication that magma is moving, but that doesn't necessarily mean that an eruption is going to happen right away or even anytime in the near future. It just tells you that magma is moving somewhere. So let's look for other warning signs. Regular old-fashioned earthquakes are another type of seismicity, and they're our third warning sign. And they're like harmonic tremor in that they're measured by vibrations detected by seismic recording instruments, but they look different when you look at the recordings of them. Here's harmonic tremor, which goes on for a long time, is kind of random, and earthquakes tend to have a very specific pattern to them. This shaking that's starts at the first wave and a second wave of arriving, and if earthquakes are really close to you, those two waves arrive at the same time, but you still see a very characteristic pattern. And this is all because the harmonic tremor and the regular earthquakes are caused by a very different motion. An earthquake is caused by two blocks of the Earth's crust rubbing against each other and moving really fast. That's different than the magma flowing through the conduit like we saw for tremor. There are actually two options for the relationship between earthquakes and the movement of magma. The first one here is that we start with magma moving into a chamber, filling it up. That chamber got bigger, pushed against the block of crust next to it, which caused it to slide past the nearby block along this existing fault, and that caused an earthquake. The other option is that we start with an earthquake, which causes a block of crust to move, and that might open or reopen a conduit, allowing more magma to flow into a magma chamber. And in both cases, we're looking at a situation where we have magma moving into some place that might eventually make its way to the surface and erupt. So when we see lots of earthquakes, we know that lots of magma is moving around somewhere for some reason. So let's take a look at a case study of what earthquakes can tell us. So here is about a couple months of data here from 2011 and 2012 from the Canary Islands again. And you can see there's a couple earthquakes a day for quite a few months, and then all of a sudden a big jump in earthquake activity. It gets quieter, and another big jump, and you can look at all these earthquakes here. So I'm going to ask you to look at this and say, where is the magma chamber? Well, here's the map view on top. If we look at a slice through the Earth, the crust is above the mantle, just like our plumbing slice shows us. But here we're seeing the plumbing lit up by earthquakes. A magma chamber that's something like between 8 and 14 kilometers deep below this island. So there was an earthquake swarm there in 2011. And in the voice thread, I'd like you to go to the next slide and make some predictions about where you think that eruption is going to happen, and use your mouse or your drawing tool to trace out how the magma will get from the magma chamber up to the surface.